Hello, my name is Kevin Kantes. I'm CEO at Hydroscope. Hydroscope is part of a Dutch drinking water company. We normally perform risk assessments for drinking water systems. But in 2018, one of our wastewater treatment plants was related to a Legionella outbreak in Boxtel. That is why we have specialized us in risk assessments for wastewater. We have visited more than 50 plants and analyzed more than 3,000 water and air samples. This presentation is a short summary of our knowledge. All known Legionella outbreaks related to wastewater have two things in common. One, they are all biological treatments, and two, they are all operating under water temperature of more than 25 degrees. Looking at our own samples, the average Legionella concentration is multiplied by a factor 10 with 5 degrees increase of water temperature. This points out that temperature is the most important factor of Legionella growth in wastewater. In most of the water samples, we detect Legionella pneumophila serotype 250. At a temperature at about 35 degrees, Legionella pneumophila serotype 1 is more present. Above 40 degrees, the performance of a wastewater treatment plant is reduced. That is why the plant is always operating below 40 degrees Celsius. It is very difficult to precisely detect Legionella in wastewater. We compare different methods. All methods need to be diluted more and more as the biological activity grows. We mainly use the culture method to detect Legionella using multitof for confirmation. This is because we are mostly interested in viable bacteria and the culture method is commercial, available at low cost. This is a simplified picture of a biological wastewater treatment plant. The water coming out of the factory is called influent. At the first step, the bigger parts of the influent are separated from the water by filtration. After that, the water is biologically treated. Organic components and physical nutrients are converted to sludge formed by bacteria. The bacteria needs oxygen to do that. That's why the tank is aerated. At the end of the process, the sludge is separated by the water. The water and the biggest part of the sludge are discharged. A small part of the sludge is returned to the beginning of the aerated tank. More and more often, anaerobic reactors are used on wastewater treatment plants. With an anaerobic reactor, it's possible to create biogas. Also, you can save a lot of building space. In a lot of cases, we detect Legionella in the influent. Due to a lack of oxygen, Legionella is reduced in the anaerobic reactor. But at the beginning of the aerated tank, Legionella concentration gains extremely fast. At the end of the process, the concentration is reduced again by separating the sludge from the water. That indicates that a big part of Legionella concentration is growing within the sludge. Further on in this presentation, I will zoom in on the most important treatment steps. We have done an internet survey with the Dutch Industrial Water and Energy Association. 39% of the respondents found Legionella in the influent. We also investigated if there were a relation between the type of industry and the Legionella growth at the treatment plant. We discovered that animal-related wastewater is more sensitive to Legionella growth than non-animal related wastewater. We also see much Legionella growth in the paper industry. We see a difference between factories that are using an anaerobic reactor. Most of the reactors need an extra nutrition for a good operation. That is possibly why Legionella is growing in this type of industry. The next step is the anaerobic reactor. In the anaerobic reactor, due to a lack of oxygen, Legionella is partly killed or getting in sleeping conditions. But there are three issues that generate an optimal condition for Legionella growth afterwards. The first issue is the creation of amino acids. The reactor works on anaerobic degradation. Biogas is formed in 4 steps. In the first step, protein is converted to amino acids. Amino acids are important for Legionella growth. In the second step, amino acids are converted to fatty acids. The degustation is never 100%. We measured higher Legionella concentrations after a bad conversion rate of the anaerobic reactor, suggesting that water contains more amino acids. The second issue is the water temperature. An anaerobic reactor operates best with a water temperature of about 35 degrees, and that's perfect for Legionella growth. The third issue are dead cells coming out of the reactor. Legionella survives longer without oxygen than other aerobic bacteria. We don't know for sure, but we suspect that Legionella can be viable but not culturable during anaerobic treatment. After anaerobic treatment, there is less competition of other bacteria. Legionella is also known to be necrotrophic, using dead cells to feed themselves. After the anaerobic reactor, the wastewater is aerated to create sludge. Sludge is created by the growth of amoebae and bacteria clamping onto each other. The sludge is growing bigger and heavier. It is sinking to the bottom and separated from the water. We see very fast Legionella growth at the first stage of sludge formation. We don't know how Legionella is growing, but we suspect it grows within amoebae. But we also suspect the presence of free-swimming Legionella cells, which are easily to airborne. This graph shows Legionella concentration in different wastewater treatment plants. Although temperature is the most important growing factor, we see the difference between plants with or without an anaerobic treatment step. Plants with an anaerobic treatment step got higher Legionella concentrations at the same temperature. In the Netherlands, 10 to 20% of the biological treatment plants are using an anaerobic reactor. Anaerobic plants produce biogas. Because of the need of sustainable energy, the number of anaerobic plants are growing. Although some high Legionella concentration, Legionella is not growing in every plant. It's not right to point out all plants as riskful. To get a good picture, you need to measure a plant for a longer period of time. The most common way of sludge separation is by using settling tanks. The sludge is sinking to the bottom. A settling tank reduces the water concentration with about 10,000 CFU a liter. Another way of separation is by using ultrafiltration. To avoid filters getting polluted, the filters are roughly aerated, causing lots of aerosols. This was the case in Boxtel. Sometimes sludge is further dewatered. Because the sludge is containing high Legionella concentrations, some types of dewatering can be riskful for employees. There are three main ways for Legionella transmission. The first way is by the route of the effluent. Effluent can be discharged on surface water or sewage. Effluent can directly or indirectly be reused for cooling towers, irrigation systems, or air scrubbers. This can cause further transmission. The second way is by using the sludge. Sludge is mainly burned or pasteurized, but sometimes it is used to start up other wastewater treatment plants, risking contamination. The third way is by aeration on the plant. The most riskful step is the aerated tank. Sometimes water is also vaporized for cooling processes. In Boxtel, there were patients infected throughout the aerated tanks. The patients were located up to a distance of 5 kilometers. Employees are also in risk. They are exposed to aerosols during cleaning, sludge dewatering, or maintenance. These are some examples of aeration types. You can imagine that some types of aeration are creating more aerosols than others. Mainly used is fine bubble aeration. Here's another one. At older treatments, cascada aeration is used. Sometimes rotor aeration is used. Here's another example. In Boxtel, coarse bubble aeration is used. The bubbles are not only used to provide oxygen, but also to clean the membranes. In some scarce cases, nebulization is used. We are using air measurement to point out the risk of transmission. We use the Coriolis mu to detect Legionella in the air. The bacteria are captured in a fluid. The fluid is analyzed by using culture or PCR. We only perform air sampling at higher water concentrations above 1 million CFU a liter. We took about 230 air samples directly above the aerated tanks. 21% of the air samples contains Legionella. We also performed aerosol measurements. We are using a mobile optical particle sizer to do that. Due to the risk of inhalation, we detect particles within a range of 2 to 10 micron. As you also could see on the pictures, nebulization gives much more aerosols than fine bubble aeration. Besides the aeration type, factors such as water concentration and weather conditions are important factors for transmission. For example, at foggy weather conditions, the concentration of Legionella can increase above the rated tank. Due to a lack of UV, the bacteria can survive longer. I also suspect that the life cycle stage of Legionella can be an important factor. Free-swimming cells are mainly shorter and easily to airborne compared to cells growing within an amoeba. Wastewater treatment plants are designed for specific characteristics. Changing it will impact the performance. For example, when reducing the water temperature, you need a bigger plant. That is why we haven't found ways yet to reduce Legionella at low costs. But we found some ways preventing the transition of Legionella. In Boxtel we placed a roof on the plant. The air is dried by the demister and disinfected by UV radiation. Summarized, there are a few lessons to learn. 1. Legionella can grow in hot biological wastewater treatment plants. 2. Animal-related wastewater is more sensitive for Legionella growth. 3. Legionella growth faster after anaerobic treatment. 4. It's still unknown how Legionella is growing, in or outside of sludge. 5. Airborne of Legionella is depending on the type of aeration. I hope in the future wastewater is getting more and more sampled as part of source tracing during Legionella outbreaks. Thank you for listening to my presentation. Please download our report Legionella in Wastewater from our website at www.hydroscope.nl. Thank you.